Namaskar everyone. Today we will simulate one circuit which is meant for lightening this LED whenever night falls. Or in other words, this LED will start glowing whenever ambient light or the sunlight falls below certain level. The main element of this circuit is operational amplifier LM741. Operational amplifier LM741 is connected to resistances R1, R2, R3 and R4. We can see resistance R4 is a photoresistor. Resistance of a photoresistor decreases whenever light falls on it. This circuit is powered by a 9 volts battery. When it is daylight and ambient light is sufficient, at that time voltage at this point or the voltage at non-inverting terminal of the operational amplifier is equal to voltage at this point or the voltage at inverting terminal of the operational amplifier. Because of the fact that during daytime, in presence of light, voltage at this terminal is equal to voltage at this terminal, so voltage at the output terminal of op-amp becomes 0 and LED does not glow. Whenever light falls, intensity of light comes down or night falls, resistance of this resistor starts increasing and voltage at this point becomes greater than voltage at this point. And because of that, output voltage of op-amp increases and that results in glowing of LED. Now let us try to simulate this circuit on Tinkercad. So this is environment of Tinkercad. We will first of all search one breadboard here. So here we have one breadboard. Then we will bring one battery. Here we have a battery. Let us power the breadboard with the battery. Now let us bring LM741 operational amplifier. And let us bring some resistances. We will require 3 resistances. So 1, 2, and 3. Let us rotate them. So all these resistances, 3 resistances I have selected of 1 kilo ohm. According to the circuit, these resistances have to be connected in such a fashion that one resistance is connected between 5 volts positive and 9 volts positive end, and the inverting terminal. Another resistance also between positive of battery and non-inverting terminal of op-amp. Then this resistance between ground and non-inverting terminal of op-amp. And let us look at the circuit now. You can see in this circuit that this photoresistor is connected between uh, non-inverting terminal of op-amp and ground. So like this. Now to simulate photoresistor, we will put a potentiometer, because the resistance of photoresistor also changes, is variable. So that change in resistance we will manage through a potentiometer. So this potentiometer, so we have connected it to non-inverting terminal. Let us check it again. Yes, it has to be connected to non-inverting terminal. Now, now in this circuit, what else is remaining? This has to be connected to plus 9 volts. This is output. Now this output, for output, we have to connect one LED. So here is one LED. To measure the voltages in this circuit, let us bring two voltmeters and place them here. One voltmeter will place here and another we will place somewhere else. Let us say we place it here or here, right? So through this voltmeter, let us find out how much is the voltage at the inverting terminal. And through this voltmeter, let us find out how much is the voltage at non-inverting terminal. Let us keep the resistance here 2 kilo ohm. So it is 2 kilo ohm here, 1 kilo ohm here, 1 kilo ohm here, 1 kilo ohm here. Now let us start the simulation. There's some error here. So this has to be connected to ground here. Now let us start. So now at the inverting terminal, we have 4.49 volts, and at the non-inverting terminal, the voltage is 4.49 millivolt. So voltage at inverting terminal is more. So the output of the amplifier op amp is in negative voltage, and that results in reverse bias of LED, and LED is not glowing as we can see. As we change this resistance, you can see voltage at non-inverting terminal of op amp increases, but still now also it is lesser than voltage at inverting terminal of op amp. Now if we increase this resistance more, a stage will come when this voltage would become equal to more than the voltage, when this voltage at non-inverting end would become more than the inverting end. And when this happens, immediately LED glows. You can just see when voltage at both the terminals of op amp, by both I mean inverting terminal and non-inverting terminal, are same, then LED glows. Now this simulates how this is simulating LDR or light detecting resistor is, we can imagine as if now at this stage it is daytime, and since it is a daytime, the voltage at non-inverting terminal is low. But as it becomes night, voltage at non-inverting terminal becomes more than the voltage at inverting terminal, and due to that, output of the op amp becomes positive voltage, and that results in glowing of the LED.